June 10, 2008, Damascus International Airport, Syria. An Airbus A310 is being prepared for an international passenger flight to Khartoum, the capital of Sudan. Sudan Airways Flight 109 was the return leg from Amman, Jordan to Khartoum, Sudan, with an en route stop at Damascus, Syria. Khartoum, the capital of Sudan, is located where the Blue Nile and White Nile rivers meet in northeastern Africa. Flight 109 has 11 crew members and 203 passengers on board, for a total of 214 occupants. Flight 109 takes off in the evening from Damascus Airport to Khartoum, Sudan. Now let's see what really happened. This Airbus A310 was not in perfect flying condition, as it departed with an unserviceable and inhibited number 1 engine thrust reverser. It had arrived from Cairo the previous day with this issue, which was documented per the minimum equipment list procedures as a carry-forward defect. A minimum equipment list, MEL, is a document that lists the equipment and systems on an aircraft that can be inoperative under specific conditions, while still allowing the aircraft to be considered airworthy and safe to fly. It outlines which components must be working and which can be temporarily non-functional, ensuring the flight can proceed without compromising safety. This helps airlines manage minor technical issues without causing delays or cancellations. Thrust reversers are used to slow the plane down during the landing sequence by redirecting some of the high-pressure exhaust forward. It is possible to operate a plane with one thrust reverser disabled. When this happens, the pilots will need to perform additional procedures during landing to compensate for the inoperative thrust reverser, but it does not typically pose a significant safety risk. Flight 109 was normal, but when it was approaching Khartoum in Sudan, there was very bad weather with heavy rain, so the captain decided to divert to Port Sudan, which is located on the eastern coast of Sudan. Flight 109 had to wait on the ground at Port Sudan for about 1 hour and 15 minutes. After being informed that the weather was improving in Khartoum, the captain decided to continue the flight. As Flight 109 received clearance to perform a night approach to Khartoum Airport, the weather was rainy and gusty. The pilots were informed by the controller that the wind was 320 degrees at 7 knots and the runway 36 was wet. The crew prepared the aircraft for landing at Khartoum Airport. The aircraft overran the runway, coming to a stop 215 meters beyond its end. The captain was unable to slow down the aircraft or stop it before the runway ended. It then caught fire on its right side. 184 people from Flight 109 managed to escape the aircraft, but sadly, 29 passengers and 1 crew member lost their lives. Additionally, 17 occupants suffered injuries. As fire started on the right side of the aircraft, slides were deployed only on the left. The rear left slide was unusable due to the aircraft's height, forcing passengers to use the middle or forward left slides, causing a pileup. The fire quickly spread to the forward fuselage and cockpit, filling the cabin with intense flames and thick smoke. The smoke and nighttime darkness hampered the evacuation, which was further aggravated by panicked passengers. The overrun was caused by a combination of a long landing flare distance of 900 meters from the runway threshold, the wet runway, landing without auto brakes, and 1 deactivated engine reverse in rainy conditions. When the captain activated reverse thrust on both engines to slow down the plane, the inoperative reverser on one engine caused an imbalance, resulting in the plane veering to the right. Reverse thrust typically helps stop the aircraft by directing engine power forward. However, with one reverser not working, combined with low visibility, heavy rain, strong winds, and a wet runway, braking effectiveness was reduced, making it challenging for the captain to safely stop the aircraft. The crew was informed that they would be landing with a 7 knots headwind, which typically helps slow down the aircraft during landing. However, it turned out they actually had a 15 knots tailwind, which pushes the aircraft forward instead. This incorrect information contributed to the crew flaring the aircraft too late during landing. Flaring refers to the upward movement of the nose of the aircraft just before touching down, which helps reduce landing speed and ensures a smoother touchdown. Because they were expecting headwind assistance that wasn't there, they ended up landing too far down the runway, which made stopping the aircraft safely more difficult. The Airbus A310 had already experienced fuel leakage from both the left and right wings. Upon hitting ground structures, such as antennas and approach lights, with the right wing, this aggravated the leakage, leading to a fire starting once the aircraft came to a complete stop. But why did the pilot decide not to deploy the auto brake, even though the controller had informed him about the slippery runway? The auto brake system in an aircraft is designed to automatically apply brakes during landing, helping to slow down the plane more effectively and consistently. This is particularly useful on slippery or wet runways, where manual braking might not be as efficient or safe. Despite being informed about the slippery runway, the pilot might have decided not to use the auto brake due to the deactivated reverser on the number 1 engine, preferring manual braking to have more direct control over the landing process. However, in wet or slippery conditions, using the auto brake is generally recommended to ensure the aircraft can slow down safely and effectively. Another factor that could have led to more fatalities in the accident of Sudan Airways Flight 109 was the delayed arrival of fire services at Khartoum Airport. This delay was exacerbated by a severe shortage of firefighting personnel and inadequate communication between the fire station and the vehicles.